I wanted to go over what you need to do for exercise 26. So for exercise 26, here's the sheet that I've given you that you can type your answers into. And it tells me that this data for this comes from a section called Data for Additional Computational Practice. So if I look at the book, I have this Data for Additional Computational Practice. And you can type this in manually if you don't have access to the file, but I've also created a file for you. There's an Excel and SPSS version of it that has this data typed into it, so you don't have to go through the step of doing it yourself. And let me go back to the question and see what I need to answer. So the first one is plot the frequency distribution for age at enrollment, either by hand or using SPSS. So I definitely want you to use some sort of software for this. I don't care if you use SPSS, Excel, or an online calculator that'll do this for you, but I want you to do some software for that. And I'm going to show you how to do it in Excel. So in Excel, I just need to make my file a little smaller so that you can see the bottom of the Excel window also. Here we go. So the sheet I've created has the main sheet with all of the tabs on it, with all the information, and then I have two tabs. So one just has the information for age at enrollment, and one just has the information for education, which are the two that you need to do some analysis on. So this first question wants us to do frequency distribution for age at enrollment. So let's go back to the Excel file. So we have our data with each individual data point typed out, and then I also went ahead and summed up this data into ranges for you. There's different ways that you can figure out the frequency in each range. You can do a COUNTIF function under insert functions and tell Excel you only want certain values. You could also count it by hand if there's not that many data points, so it just depends. One of the first things I would do when I'm working with data and I've got to figure out how many are in each range is probably sort that. If I can come up here and just select what you want because you've got that table underneath it. And it's going to ask if I want to expand the selection, and I do. So it'll sort this range, and that lets me just kind of see how many are in each range. If there's not that many, you can just count them up. If you have quite a few, then you can do some formulas. And this should actually say 39 here. Sorry about that. Okay, so there's two ways that I can do this in Excel. I can use the histogram function in the analysis toolpak, or I could do the insert chart function, because what I want to see is that display that shows me a graphic display of how many are in each range. So the first way I'm going to show you to do it is using the analysis toolpak. So to use the analysis toolpak, I need to tell it how I want my data grouped. Here I have the data all summarized already, but that won't work for the analysis toolpak because it automatically runs that as part of its functions. So if I use data that's already grouped, it will give me a really funky result. I have to have each individual data point to use the analysis toolpak. So I need to tell it how I want my data grouped, and a bin is just a category for how I'm dividing my data. It's that range that I'm going to use. And I enter in the upper limit for my bins. So I'm going to enter in those upper limits. And I'm going to leave this one blank because the last category it'll do is it'll give me everything that's above the last point I entered. So now I'm going to go to the analysis toolpak, and I'm going to choose histogram. It's showing up for me because I just used it recently. If it's not showing up for you, just search through there and find it and click OK. And I want to select my data range, which is already showing up because I ran this recently, but I will select it there. And then I need to tell it where my bins are, so it knows where to get those upper limit values. And then I selected these labels here. If you did that, you need to make sure the labels button is checked. And then the other thing I like to change, it'll default to a new worksheet. I like to put it onto the same chart so that it's all together. So I'm going to tell it where I want the chart to go, and I'm just going to click somewhere nearby my data, but make sure it's not overlapping my data that I have. And then you need to click this chart output button, and that will give you the chart that you need. And just so my chart doesn't look identical to yours, because you do need to do this for homework, I'm going to change this range just slightly so it won't be identical. Okay, and I'm going to click OK. And it gives me this output. And so you can see that these bins here represent that upper limit. And now I can come in here and I can change this to whatever label I want. And I want this to be my under 39 and 40 to 44, just so I have that range so it's a little bit easier to interpret. And then this is 55 to 59. And note, you don't want your range to overlap. I can't say 40 to 45 and then 45 to 49, because if there was a value of 45, it wouldn't know where to count it. It would be confused or count it twice. So you can't have overlap here with your ranges. And then the last one, I'm just going to make my 60 plus group. And my values are a little different than yours, remember, because I didn't select those last two ranges. I don't want to give you the exact answer on the homework. But it's going to look something like this, and then I can change the title here. I want this to be the frequency of age of enrollment, or something that makes sense. We need to make sure that our labels make sense with our data. And then I should change this to be age at enrollment. And then it's okay over here saying frequency. But what I don't need is a legend. I really just don't need that. So this is what my chart will look like. Yours will look slightly different. The other thing I can do with a histogram is actually to format the width on this. You need to click on the bars. Do format. I don't know why this is showing up so large. And the gap width is this distance in between the bars. With the histogram, they're typically very close together. But you can adjust that, have a little space or have a lot of space between your bars. So this is how I would do it with the analysis toolpak. If I wanted to do the insert chart function, then I would need my data summed up like this, which is why I gave it to you this way. So to insert a chart, I would select this data. And I'm not going to select the last row because, again, I don't want mine to look identical to yours. So I'm going to come here to Insert Chart, and I'm going to click All Charts. And what I want is a column chart. This is showing me what it's going to look like. I want that column chart. So I'm going to click OK, and it'll insert it. I'm going to move that down a little bit. So this is what my chart looks like. Again, I didn't select that last row, so yours will be a little bit different. And it's telling me how often each of these occur in that data set. So the thing I need to do is change my title here so that it makes sense. So do something like age at enrollment. Title that makes sense with the data. There are different things that you could do. I also want to change the layout on this. If I want to make it look like a histogram, there's actually an option in here for that. But I definitely want to do some labels on it. I'm not liking any of these. Okay, I do like this one because it has labels on both. So I found that under the quick layout. And I just went to this one because it has titles on the both of the axes. So I'm going to change this title to say age. And I'm going to change this title to say frequency. And I don't need a legend. Again, it's just one variable I'm looking at, so I don't need that legend there. Other things I can adjust would be the gap width, like I did before. I can adjust the color of the bars. I can come up here and select a different color if I want to for it. So I don't like how this is being displayed over here with the half increment, so I can change that if I want to. And this is under the format axis, so you would right click on this and do format axis, and then find the axis options, and this is asking me what I want for my upper limits. I'm going to set this actually probably to 6 just so you can see a little space above it. And then it's asking me about major units, and I want the major units to be just 1. I don't want it to be showing those half. Okay, so it's not showing the halves anymore, so I like that. So that looks good to me. If I need to adjust anything else, a lot of those adjustments would be in this area. Oh, another thing I can adjust is take out those lines. So let me get back into the format axis area. And what I'm looking for are the grid lines. And if I don't want grid lines, I just do no lines and it'll take those grid lines out for me. So there's different options you can make to make it look the way that you want it to, but this is what we're looking for with the frequency distribution. Now, you could upload this file, the Excel file, but you can also just click onto this, click onto the chart, and Control-C or right-click to copy it. Go back to your Word document and just paste that right in there. Make it smaller if you want to. By clicking in the corner, which it's not liking for some reason, there we go. And make that smaller if you want to, but that's your frequency distribution. So the next thing we need to answer is the skewness for the distribution in question 1. So we want to know what this looks like. Is it a normal distribution or is it skewed? Well, the best way, before I move on too much, let me just show you that you can use an online calculator for the histogram. There's some calculators like this that you could use, and the way that you group your data will change the display a little bit, and that's okay if you grouped it differently as long as you have the right information. So I'll provide you these resources. There are some online programs you can use. Okay, let's go back to question 2. We need to look at the shape of that distribution. And in Excel, I can do this using the descriptive statistics feature in the analysis toolpak. So if I go back to my analysis toolpak, I want to look for descriptive statistics and click OK. And I need to tell it where my data is, and I'm looking for age of enrollment, information from that. My data is grouped by columns because it goes vertically. And then I did select that label, so I need to tell it about that I did that. I'll change my output range to be somewhere on the same chart. So it's getting a little crowded, I'll just put it down here. And then I need to tell it I want summary statistics. That's going to give me the statistics that I need. Everything looks okay, click OK. And it's going to give me this table with these statistics. So you can see here I get my mean, I get my median, my mode, my standard deviation. It also gives me my kurtosis and skewness. And those are what I'm going to look for in Excel to look at whether or not my data is skewed. And that's just telling me, what's my distribution shape like? Is the distribution of my data, is it normal? That bell curve? Is it spread more to the left or spread more to the right? Okay, so I can tell visually by looking at my chart that my data is a little bit to the right because I have more values on this end. And remember, I didn't even select the 60 plus group. So I have more values here. So it's skewed a little bit. But if I look at this, the kurtosis and skewness are negative 0.6. So that tells me it's a negative skew. It's a negative because my skew is this way, which points towards negative values. So that's how I remember that. but it's not very substantial. For a rule of thumb, I'd be looking for skewness more or less than -2, and then for kurtosis of more or less than -2. So these aren't very, it's skewed a bit, but it's not substantially skewed. Now remember, I'm not selecting all of the data, so yours will look a little bit different. So look at that and interpret it. And let's go back to this. The next one is to compare the original skewness statistic and Shapiro-Wilks statistic with those of the smaller data set. Now, I care more about being able to interpret skewness based on the Excel statistics or basic statistics. Shapiro-Wilks is a very complicated statistic, and we'll talk about it a bit in class, but just give me some interpretation of what you think that data shape looks like. So now I need to do the same thing with the distribution for years of education. Again, I want you to do this in some sort of program. So if I go back to Excel, on this tab I have the information for education, and you just need to do those exact same steps as you did for age. So you can either use the analysis toolpak, or you can use this table that I gave to you here, and you can do the insert chart function. So remember, you highlight your data. I'm not selecting it all. But we would do insert chart, and we would insert a column chart. And this looks like what I want it to look like. So I insert that, and I would need to make my adjustments to it so it would have titles and display how I want. So it's just the same steps we already did for the for age. Oh, and I need to change this title I put here. This is actually frequency for years of education, just to not confuse you. Okay, so go back to your Excel or your Word doc file, and then once you have that chart, copy paste it in here, or you can upload the Excel file if you prefer. And then how would you characterize the kurtosis? Well, that was one of the statistics given to us when we did the descriptive statistics. So you just need to run these descriptive statistics again, and this time we're looking at kurtosis, which is real similar to the skewness. That's not always the case, but it happens to be the case here. Kurtosis is telling us about how tall our distribution is. Are most of our values in the middle? Are they spread out a bit or spread out a lot where it's really flat? And so this is what you're looking at here. And again, we can interpret that with more than 2 or less than 2 would be considered substantial kurtosis. So give some interpretation of what you think it looks like. And what's that distribution look like to you? Before we move to the next questions, I want to show you how you can do descriptive statistics with an online calculator. So I'll provide you with some links, but also if I'm just look for descriptive statistics calculator, I can find some that will calculate the description, and you just would copy paste your data over into that calculator. Make sure you get the raw data points, each individual point, not the one that's already summarized for you. Okay, so this calculator is giving me my skewness and my kurtosis of the data. Some calculators will give you all of that, some give you part of it. And so you could specifically search for skewness or kurtosis calculator also. I want you to have these options in case you can't get it to work in Excel. I want you to have another way to do it. So I'll give you some links for those calculators. You can use those as well if Excel's not working for you for some reason. So next problems are in SPSS to compute the Shapiro-Wilks statistic. So I don't care about that as much. What I'd like you to do is just look at the skewness and kurtosis. So use Excel to do that, or the online calculator for number of times fired from job, and give me some analysis on what you think the distribution looks like. So here, this just wants you to compare these two tests. Just give me some, little general information about the two. I don't care if you're not an expert in it, just maybe that you've read through and you kind of know what they're doing. How would you explain the skewness statistic for a particular frequency distribution being low? when the Shapiro-Wilk statistic is significant. So this is getting at that we have a significant result on the test, even though our skewness is low. And it's common for that to conflict because the test we're doing is looking at the entire shape of the distribution. And this is one of the reasons why some people think that those specific tests aren't any better than just looking at the skewness and kurtosis and making an interpretation. That's why I want you to kind of look at it that way, because we have these fancy tests, but there's a lot of debate about whether they're really better or not. So just give me some of what you think your ideas would be for why you would see that conflict here. And that's what we need to do for exercise 26. Make sure you put your answers in there and then upload that in LabCloud.